So let's talk about this simple problem. An athlete completes one round of a circular track of radius r in 40 seconds. So what will be his displacement at the end of 2 minutes and 20 seconds? You can pause the video and try to find the answer. So let's analyze this. The total time of motion is 2 minutes and 20 seconds. Well, 2 minutes and 20 seconds is 1 minute is 60 seconds, so it is 2 into 60, that is 120, plus 20, that is 140 seconds. So as the time period of circular motion is 40 seconds, in 140 seconds, well, it is given that athlete completes one round of circular track of radius r in 40 seconds. So this is the circle and this is the radius r. It is going to complete in 40 seconds. But now you have total 140 seconds. So athlete will complete 3.5 rounds. So he will be diametrically opposite. So 3.5, that means if we start from A, he is going to be at B. So the displacement is going to be 2r. So this option B is correct. So let's talk about the next problem. A cyclist starts from the center O. Well, he starts from the center O of a circular park of radius 1 kilometer, reaches the edge P of the park. So he starts from O and moves like this and goes to P. Then cycle along the circumference and returns to QO. So he goes like this and then comes back like that, as shown in the figure. If the round trip takes 10 minutes, the net displacement and average speed of the cyclist in meter, the displacement in meter, and the speed in kilometer per hour, we need to find out. So the net displacement is 0 because he starts from O and come back to O. And the total distance is going to be OP plus PQ and QO. So OP is 1 and PQ is, the total circumference divided by 4. So 2 pi r divided by 4 plus 1. So that gives me the value as 14.28 divided by 4. Now, the average speed. The average speed is going to be the distance, which is 14.28 divided by 4 and divided by minutes, which is 10 minutes. 10 minutes, or we have to make it as second. Okay, no, this is, he wants kilometer per hour. So 10 minutes divided by 60. So we get this value as 21.42 kilometer per hour. So option D is correct. Let's mark it this way. Option D is correct choice. This is also quite interesting problem. The displacement time graph for two particles A and B are straight lines inclined at an angle of 30 degree and 60 degree with the time axis. The ratio of velocities of VA and VB is, and these are some options. You can pause the video and try to find the answer. So let me explain the tip and trick. The velocity can be calculated as tangent on the displacement time graph. So VA by VB, velocity of A and velocity of B, is tangent theta A divided by tangent theta B. Well, this you need to remember very well. That is tan 30 degree, tan 60. The value of tan 30 is 1 by root 3 and tan 60 is root 3. So the value is 1 by root 3 into root 3. So this is 1 by 3. So this option E is correct choice. This is a very interesting problem. A bus begins to move with an acceleration of 1 meter per second square. A man who is 48 meter behind the bus starts running at 10 meter per second to catch the bus. The man will be able to catch the bus after, and some values are given. So let's do it with the graphical. The bus begins to move with an acceleration of 1 meter per second square. So this is the bus and it is moving with acceleration A as 1 meter per second square. Okay, the man who is 48 meter behind the bus, so there is a man who is at 48 meter behind the bus and starts running at the velocity, you can say, at 10 meter per second. The man will be able to catch the bus. So let's do the solution. Let the man will be able to catch the bus after t seconds. Then the distance covered by the man is going to be the distance covered by the bus plus distance of man to bus. So the first is, we can take this, the distance of man to the bus plus the distance covered by the bus as the bus is moving. Well, distance covered by the man is tan t. Why tan t? Because the man starts moving with the velocity at 10 meter per second, and in time t the distance covered will be 10 t. Now distance of man to the bus is 48, which is given. Now how much the bus is going to move? This is half at square. Well, we have this equation. Let's sort it out. And this equation is 10t is equal to 48 plus half 1 into t square. So after simplification I get t square minus 20t plus 96. So we can factorize, and factorization 96 is equal to 12 into 8, and the sum of 12 and 8 is 20. So we get factors t minus 12 and t minus 8. So this gives me t is equal to 8 second and t is equal to 12 second. Well, thus man will be able to catch the bus after 8 second. Why not 12 second? Because that value will be absurd. So let's look at the option. Option E is correct choice. So similar to the previous problem, let's solve this question. A man is 45 meter behind the bus. When the bus starts accelerating from rest with acceleration 2.5 meter per second square, with what minimum velocity should the man start running to catch the bus? So let me display the solution. Let's start with that working. Let the man will catch the bus after t second. So he will cover a distance of ut. Similarly, the distance traveled by the bus is going to be half at square. So for the given condition, the distance covered by the man, that is ut, will be the distance of man to the bus, which is 45 plus half at square, or 45 plus 1.25 t square. Why? Because acceleration A is 2.5. So u is equal to 45 by t plus 1.25 t. We get this equation. Now, to find the minimum value of velocity, we need to differentiate du by dt is equal to 0. So we get t is equal to 6 seconds. Now what to do? Let's put this value of t is equal to 6 seconds here. So u is equal to 45 divided by 6 plus 1.25 into 6. So 1.25 into 6 is 7.5. That is also 7.5. So the minimum velocity is 15 meter per second. I hope you get the answer. Let's look at the choice. This is the option. This is the correct option, C.